Brief history of operations management. Historically speaking, the field of operation management had evolved in a very short span of time. Its roots, however, go back to the concept of division of labor advocated by Adam Smith in his book The Wealth of Nations in 1776. In 1832, Charles Babbage, a mathematician, extended Smith's work by recommendation the use of scientific methods for analyzing factory problems. However, the era of scientific management, as it's now known, started with the work of F. W. Tyler in 1878, who subsequently came to be recognized as the father of scientific management. Tyler is credited with recognizing the potential improvement to be gained from analyzing the work content of a job and designing the job for maximum efficiency. His experiments conducted on the shop floor without about significant and rapid increases in productivity. He explained the four principles of scientific management in the following way. A. Development of a science for each element of a man's work, thereby replacing the old rule of thumb method. B. Selection of the best workers for each task and then training the and developing the workman on individual basis. C. Striving for cooperation between management and the workers to stimulate simultaneously obtain both maximum production and high worker wages. D. Dividing the work between management and workers so that each is working on what they are most proficient in doing. Tyler described his management philosophy in a book, The Principles of Scientific Management, published in 1911. This event, more than any others, can be considered as the beginning of the field of operation management. The colleagues, contemporaries, and followers of Tyler were many and included the following peoples. Frank Gilbert and his wife Lillian Gilbert are recognized for their contributions to motion study. Gilbert developed the concept of thermalics and chronocyclographs for motion study in 1911. Lillian Gilbert wrote her book The Psychology of Management, which was one of the earliest works concerning the human factor in organization. In 1931-3, Henry Ford developed the concept of mass production and arranged workstation into an assembly line with moving belt. In 1913, also Henry Gantt made his best known contribution in charting the production schedules using a visual diagrammatically tool which is popularly known as Gantt chart and is effective practical tool even today. In 1913, Harrington Emerson applies Tyler ideas to develop organization structure and suggested the use of experts in organization to improve efficiency. Wilson developed the concept of economic order quantity EOQ in 1928, which is still recognized as the classical work in the scientific analysis of inventory system, and work of subsequent researchers were essentially further refinements of Wilson's lot size formula. In 1931, F. H. Dodge, H. G. Roming, and W. Seward developed the concept of sampling inspection and published statistical tables. Earlier in 1924, W. Seward pioneered the concept of statistical quality control and developed control chart of the monitoring the quality of production processes. In 1933, Alton Mayo conducted his famous experiments at Western Electric's Hawthorne plant looking at into human and social aspects of work. This paved the way for the behavioral schools of management. Myers felt that scientific management often emphasized technical skills at the expenses of adaptive skills. Some other notable development in these lines includes the concept of managerial grid developed by the Robert Blake and Maslow hierarchy of needs and Douglas McGregor theory X and theory Y in management. In 1937, LHC Trippett developed the concept of work sampling to cause the level of machine and manpower utilization and for setting work standards in and around 1950. Two major developments that influenced operation management were the emergence of techniques of operation research beyond military contexts and developments in engineering offered by LD Miles. The OR is application of scientific methods so to study and devise solution and managerial problems in decision making. Usually mathematical models and the system approaches OR has helped solve resource allocation, scheduling, processing, inventory, location, layout, and control problems. Techniques of value engineering helps in efficiently identifying the unnecessary cost so that products and systems could perform their functions at minimum costs. Development in computers led to computerized applications of industrial engineering and OR techniques to production management problems. Development in MIS and DSS decision support system provided a further fillip to the developments in operations management. In 1958, the concept of CPM and PERT were developed for analysis of large projects, and since then a number of network-based techniques of project management have been developed. In the late 1950s, scholars and researchers in the field began to generalize the problem and techniques of manufacturing management to another production management such as petroleum, chemical and other processes industries, leading to the emergence of the concept of production management as a functional management discipline. In the late 1960s, the concept of operation management expanded to include the service sectors as well. Only recently, the service sectors has received as much attention as production sectors from the point of view of scientific management of systems operation. System approaches taking a holistic, integrated looks at the problem of operating a system emerged in the 1970s, which considered the interplay of various subsystems in organizations. Development in the computer simulations of integrated productions inventory systems are some of the current thrust in modeling of productions management problems. In the more recent past, there have been a major thrust on the adoption of Japanese management techniques like the just-in-time system or Kanban system for production scheduling and inventory control and the concept of quality circles (QC). These concepts have apparently done well in Japan context but should be continuously adopted in other situations only if external work environment and work ethos make them appropriate elsewhere too. Others notable developments in recent past have been group technology (GT), the cellular manufacturing system (CMS), flexible manufacturing system (FMS), computer aided design, manufacturing, CAD or CAM, etc. Thus, future of operations management looks bright.